The map of marine ecosystem types is really the foundation for ecosystem assessment, and we deliberately keep improving this map. So it's designed for iterative improvement. This is one of the most important aspects of our work in marine ecosystem assessment. We're always trying to improve and try and schedule improvements. This map is in its third iteration, and the last version in 2011 actually split benthic and pelagic ecosystem types. They were combined in 2018, and we are currently wrestling with the decision in this context at the moment. The work to compile the marine ecosystem map is convened through a marine ecosystem committee, and there's a whole network of marine scientists and many data sets that underpin this map. The kinds of data sets that are included in this include data sets that reflect on depth and bathymetry, so both side scan, multi-beam, single beam bathymetric data. There is a rich set of data about the nature of the seabed, so in terms of also drawing from the side scan, the kind of seabed, whether it's hard or soft or consolidated or unconsolidated. There's information on sediment grain size. We have historical data about the seabed. There's a data set around oceanographic variables that has also been used to inform particularly the ecoregions in the map. We have data from visual seabed surveys, biotope data, so that's biological or community data that helps us determine what the invertebrate and fish communities are, so benthic macrofauna, fish data, and also infauna. We have work to help map vulnerable marine ecosystems, and finally remote sensing data, particularly in terms of our kelp forest. Here you can see some examples of the type of data that has fed into the National Marine Ecosystem Map for South Africa. In terms of bathymetry, we actually have some really large data sets that were provided by colleagues at the Department of Environment, Forestry and Fisheries. We have data sets from our academic partners and particularly colleagues working with the African Coelacanth Ecosystem Program, colleagues at the University of KwaZulu-Natal and the Council for Geoscience, and even data that has been provided by offshore industries. Our colleagues in SAMREF, which is a body that tries to bring together industry and scientists, are also advancing work in this area. In terms of the seabed, data that allows us to get an idea of the grain size is a critical input in characterizing the seabed, and we have drawn from historical and new sediment grain size data from the Council for Geoscience and from academic partners who've provided inputs. Two of the other data sets that have been really useful in advancing South Africa's marine ecosystem classification and mapping work include the work from visual surveys. So we've used remotely operated vehicles, tow and drop cameras, and baited remote underwater video and collected data in situ, and this really allows us to see these ecosystem types. So it's quite a different type of data and approach from, for example, benthic macrofauna by GRAB, or the kind of data that's collected in trawl surveys. And we've been working on this and working with many students analyzing this data, sometimes into a biotope or community type map. And on the right, you can see some of the biotope data sets. And that's where we have done analyses of species composition and abundance to define what we call community types or assemblages or biotopes. So that's the biology together with the habitat. And these have been a useful input into our marine ecosystem classification and map. In terms of our overall classification approach, we have a hierarchical classification approach, and we are increasingly trying to align with the IUCN Global Ecosystem Typology. But basically, at the broadest level, we have the ecoregions and then the key depth cuts across the shore, the shelf, and the slope into the abyss. And then at the third level, building on ecoregion and depth patterns, we introduce substratum type. And then only at the finest level is the further subclassification, which looks at more local scale drivers that affect biodiversity pattern. And these are different in different ecosystem types. So for example, on rocky shores, wave exposure is a key driver of biodiversity pattern, and on sandy beaches, the beach morphodynamic state is important. On the shelf, river input can be a key driver. But there's a range of features that we've included at that finer scale in our classification, and it's really valuable to be able to have the value of a hierarchical approach where you can nest these different elements. This map shows you our classification at the third level, where ecoregion, depth, and substratum have driven 54 different marine ecosystem types. But at our finest scale, there are 150 marine ecosystem types. And as I said, these are both the benthic and the water column components, and they reflect the full diversity of marine ecosystem types in the country. Finally, we can compile the different data sets that we've used to delineate and characterize our different ecosystem types into a map that reflects the data richness for each ecosystem type. This is what it looks like, and you can really see that there is much more data available on the shore and the shelf, with decreasing data density in the offshore environment. So this is valuable because it helps us to clarify our certainty in our assessments. And the ecosystem map is the first area in the assessment where we do have some uncertainty, particularly for our less well understood ecosystem types, and particularly considering that marine ecosystem mapping lags by a century behind our efforts in the terrestrial realm. But importantly, in closing out on this section, we keep iteratively improving this map, and an important function of our National Biodiversity Assessment is to share progress and to really reflect our knowledge gaps and our research priorities going forward. And it often helps us to catalyze the research that we need in the areas that we need it. Thank you.